Now let's move into our critical section of clean and transform data. This section will focus on the T in our ETL process, or the ELT process, also known as extraction, transformation, and loading. In this section, we're going to try to tell our organization's compelling story effectively here in Power BI. But a lot of times the data that we get is a mess. It's not sorted, it's not arranged, it's not ready to be presented visually, and we have to start really from square one getting our data together. It's a lot of heavy lifting that has to be done in order to get to the visualization of our data in reports and dashboards. This is the module we do it in. We have to scrub our data, shape our data, and do a lot of things before it can be modeled and have calculations added to it, so we can tell this beautiful story of our organization through metrics and visualizations on a dashboard or a report. Now let's move on into our critical section of clean and transform data. This section will focus on the T in our ETL process, or the ELT process, also known as the extraction, transformation, and loading process. In this section, we're really trying to tell our organization's story effectively here in Power BI, but a lot of times the data is a mess. It's not sorted, it's not arranged, it's not ready to be presented visually, and we have to start really from square one getting our data together. It's a lot of heavy lifting, and that has to be done in order to get to the visualization of the data in reports and dashboards that we want. This is the module we can do it in. We have to scrub our data or shape our data before it can be modeled and have calculations added to it, so we can tell that beautiful story of our organization through metrics and visualizations on a dashboard report. Consider the scenario where you have imported data into Power BI from several different sources, and when you examine the data, it is not prepared for analysis. This is really an all too common scenario. Dirty data can be really overwhelming, and though you might feel frustrated, you decide to get to work and figure out how to make this data model as pristine as possible. Here are some common issues that you may run across. A field containing the wrong type of data, like employment status. Many errors, misspellings, and inconsistencies with your data in several columns. Some columns may also have nulls. No one wants to run a report or view a report with a ton of nulls inside of it. There's also a primary key field that doesn't have unique values, like the customer ID field. And there could be a field that's a combination of information that should actually maybe be broken up into multiple fields. Likewise, there might also be 2 or more fields that you'd like to merge into one new field. Power BI Desktop and Power Query Editor are going to offer us a very powerful environment to clean and prepare our data. Clean data has the following advantages. Measures and columns produce more accurate results with our calculations. Tables are organized intuitively, and duplicates are removed for easier queries and easier navigation. Codes and integers can be replaced with human-readable values. We are getting your data ready for the optimal query design, a denormalized star schema. Now let's talk about some of the common tasks that you'll want to perform to clean and shape your data. Notice in our diagram that we are extracting data into Power BI as one option, then using the Power Query Editor to clean, shape, or transform our data. And then ultimately that data will be modeled and calculations will be added to it. And from there, we're going to design our reports and dashboards. All these steps can be done inside the Power BI desktop. Once the report is finished, it can then be published to a workspace in the Power BI service inside of Microsoft Fabric. From there, it can be shared out to users who can access it from their phone, tablet, laptop, desktop, or more. Some of the common tasks are renaming columns and/or tables, changing the data type, removing rows, setting the first row as header, merging fields, splitting up a field into more fields, fixing misspellings and inconsistencies, and of course, removing nulls and more. To transform or shape your data with Power Query Editor, open the Power Query Editor by selecting the Transform Data option on the Home tab of your Power BI desktop. When you work in Power Query Editor, all steps that you take to shape your data are recorded on the right in the Query Settings pane. Query Settings also allows renaming of steps and shows all the steps for your query in the order they were completed. You can right-click a step and add a description so that you can record why the change was made, and if need be, use it for auditing purposes. Each time the query connects to the data source, it automatically applies your steps, so your data is always shaped the way you specified. Query Settings Applied Steps are also your Undo button to undo the steps you want to reverse. Just click the X next to the step to undo it. From here, you can see the Queries pane on the left, which shows the tables or queries you are working with that were loaded from your data source connection. The Queries pane allows you to group, rename, remove, and disable and enable load from your queries. Notice too that it has a ribbon on the top with a number of menus, all of which can be used to help you with your transformations. There are over 300 plus transformations available in the Power Query Editor. Note too that in the center you have a query or table that you are currently looking at in preview. You can adjust the data type, you can sort your records, rename the fields, and more. Notice that we're just seeing the first 1,000 records. You can adjust that and show more if need be. There is a button at the bottom called Column Profiling, based on the top 1,000 rows, that you can click on and have it show more records if you'd like. To perform some common transformations in Power Query Editor, like renaming or removing columns, formatting, etc., use the ribbon. Notice that based on the menu tab selected, the ribbon options change. We won't cover them all, but we suggest exploring them all to know what options are available. The first step in shaping your initial data is to identify the column headers and ensure that they are in the right place. You can also add columns based on existing columns, create a custom column using the M language, or convert date and time columns to calculate age, duration in years, etc. More on this topic in upcoming sections. You can remove any columns you don't need to reduce the semantic model size for faster query performance. It's a best practice to split the date and time field into 2 separate fields for better semantic model compression, which will reduce the size of the model and again give us better performance. After completing column transformations, always make sure your data types are correct. When you import data from multiple sources in Power BI Desktop, the data retains a predefined table and column names. You might want to change some of these names so that they are in a consistent format and easier to work with, and more meaningful for your users. Use Power Query Editor to make these name changes and simplify your data structure. You may rename a query to a name that users are more familiar with. Replace values too that are misspelled or inconsistent to another curated and correct value. Here we show the replacing of the month December with the correct spelling. Consider replacing null values with a 0 or an NA or something else depending on the field. Remember, no one wants to use a report or a dashboard with a ton of nulls in it. Also remember to remove unnecessary duplicates from columns. The best practice is to give your tables and columns and measures a descriptive business term and replace underscores with spaces. Be consistent with abbreviations too, and prefaces and words like number and ID. Excessively short abbreviations can cause confusion if they're not commonly used within your organization. When you import a table from any data source, Power BI Desktop automatically starts scanning the first 1,000 rows, which is a default setting, and tries to detect the type of data in the column. Sometimes it may not detect the correct data type, which could result in performance issues. A best practice is to evaluate the column data types in Power Query Editor before you load the data into the Power BI Desktop model, and change it if necessary. This could also include applying a format to the values in a column if it's numerical or date or time, for example, and even change the summarization default for a column from sum to min, max, average, count, etc. if it's a numeric field. Incorrect data types will prevent you from creating certain calculations, deriving hierarchies, or creating proper relationships with other tables. The ability to combine queries is powerful because it allows you to append or merge different tables or queries together. Combine tables into a single table if too many tables exist, making it difficult to navigate, and it's just really an overly complicated data model. Or if several tables have a similar role and you want to consolidate those tables. You can combine the tables in two different ways, merging or appending. When you append queries, you are adding rows of data to another table. This is similar to the SQL union join clause. When you merge queries, you are combining the data from multiple tables into one based on the columns that they have in common. Usually it's a primary to foreign key, and it's similar to a SQL join. Here is an example of using append queries, which can append two or more tables together. In this example, I have 3 different tables. Notice that each table has 4 fields, all with the same names and all in the same order. This is helpful when you do an append. In Table 1, there are 3 records. Likewise in Table 2 and in Table 3. So check when the append results shows that you actually have 9 records as a result. When doing an append, I can also choose to either append and create a new table, or I can append into an existing table. It reminds me of a big copy-paste job, copying from the 3 tables here and pasting it all together in the results. If you add 2 or more tables together, where at least 1 or more tables has an extra field, you can still append. However, the results may have some nulls in the extra fields. Let's now focus on merge queries. Merge queries are very similar to doing a join in SQL. However, unlike the append, it only allows 2 tables to be merged together at one time. In our example here, we have to select the table icon in the Power Query Editor to select Merge, and then you will see the 2 tables listed inside the Merge pane. Notice we have Sales Orders and Sales Order Details. Sales Orders is the first table. Because it's on top, it is also known as the left table. Sales Order Details is the second table. Because it's on the bottom, it's also known as the right table. Down below, you can choose the type of join you'd like to do. A left outer join, a full outer join, a right outer join, an inner join, and more. Remember that the inner join looks for matches between usually the primary key and the foreign key and pulls in the corresponding records. The left outer join also looks for matches between the primary key and foreign key, but it pulls in the records from everything from the first table or the top table or the left table. The right outer join does the same thing as the left outer join, but includes all the records from the second or bottom or right table in the Edit Relationship dialog box. If the data that you're shaping is flat, in other words, it has a lot of detail but it's not organized or grouped in any way, The lack of structure can complicate your ability to look for patterns in your data. You can use the pivot column feature to convert your flat data into a table that contains an aggregate value for each unique value in a column. This can also be used to aggregate a large data set, to curate it for queries, and reduce the semantic data model. For example, you might want to use this feature to summarize data by using a different aggregate function, something like count, min, max, median, average, or sum. It pivots data from rows to columns. In this example, we have a table that has many rows and 2 fields, category name and subcategory name. We'd like to count all the records by category or the subcategories per category. We pivot on the category field and have it use the aggregate count. Notice that this takes our many records and aggregates them into one record, where we can see that there are 3 subcategories under bikes, 14 subcategories under components, 8 subcategories under clothing, and 12 subcategories under accessories. This can also be used to reduce our semantic model size and to include only the data that is commonly queried for. By contrast, unpivot columns is deaggregating our data and transferring columns to rows. Notice our source here from Excel that has been imported into Power BI, and with the fields year, 2018, and 2019. We have 12 records, 1 for each month, and the dollar amount for each year, 2018 and 2019 in each record. When we unpivot our results, now we take the one record January 2018 and 2019, and it turns into 2 records in our results. Same thing for February's sales amounts for 2018 and 19. One record in the original on the left is now 2 records in the results on the right, deaggregating our data. Now let me show you a few common transformations. So let's talk about some common transformations that you might find yourself having to do. There's, as I mentioned, 300 different transformations that you can do in Power Query Editor. You can also, of course, do these transformations inside of Fabric, and you can do it in your data lake option there with the Lakehouse. You can also do it with the warehouse in Fabric. And what we're going to be working on right now is doing data flow, and that would be working with the data flow Gen 2. So that might not be a bad option too. So you could be graphically done. Start again from there. And that would be working with data flow Gen 2. So that might not be a bad option too, so that would be graphically done for you. And that would be available in Fabric. So 300 options there also. So that's what we're going to do, is we're going to take this Power Query Editor with our queries on the left-hand side, as you can see. And this information that I pulled in was from SQL Server. It's off the Data Warehouse AdventureWorks 2022 database, and I pulled it in. In fact, internet sales, dim customer, dim date, dim product, and dim sales territory tables. And I pulled that in and I imported it, and I told it that I wanted to transform the data. So it took me here into our Power Query Editor. And I can take a look and I can see the fact table and all of its fields inside. And I want you to notice the steps, the applied steps on the far right. They're really just nothing that we've applied to it so far. So there's the dim customer table also here. And I'm going to go ahead and take a good look at this and see what kind of data we're working with. There's other tools that you can use that you might find helpful to find maybe what you'd like to do is look for nulls, or maybe you have non-unique values in certain fields and other tools that are out there that you would like to use to help you look for errors and anomalies. There's also a profiler, even through SQL, run this. So that might be a good option too to work with. But as we come here, we'd like to kind of just look around. There's my customer table. You might notice the customer table has a number of fields. There's an email address here, and you can see a little bit of that. And so there's a lot of information in here. And there might also be some fields that maybe we'd like to get rid of because we're not really going to query it. And maybe what we want to do is we might want to reduce the size of our data model. So we're going to delete some of these fields because we're not going to be using them. Um, and we'll do some cleanup here. So this is probably really the heaviest part of our work, is cleaning the data and getting it ready to be reported on. So we could take a look at a lot of our tables. There could be a lot of work for us to do here, and we can see a lot of the work is really heavy lifting in the labs also. And if you look at the lab for this module here on transformation, it might be very helpful. Here is our date table. We have a product table. So we don't have a lot going on other than product. May have a few things that have occurred. But other than that, what we're going to do as we go through this is we're going to see all the steps that have been done against it. So there's a filtered row that just occurred. And I want you to notice that as we right-click it, we get the native query that's dark. And then I'm going to select it. And what this is, as you can see, native query, when it's darkened in, it tells us that we've done query folding and that this is the optimal way to do our transformations. It means that all the transformations that were done in this step could actually be rolled up into a single select statement. So this is very, very efficient and a high-performing way to run our queries. If we can get this option to view native query, this is the best. I'm going to go up now to remove columns. And you can see view native query. It also has it. and that navigation may or may not have the View Native Query darkened in for us, and source also may or may not have it in. So it's not available everywhere. They don't necessarily have it. So some of this you can see, just like the ones that we have been inherited over, like navigation, are brought in. So what I'm going to do is let's take a closer look at the product table. And what I'd like to do at the product table is something I mentioned in the lecture, and that is splitting date and time. So as I look through the product table, you may notice, actually we go back to filtered rows so that you can see there's been a little bit of filtering here with the filtered rows. But I'm going to scroll through and I'm going to pull up our start date here. And it has both the date and time inside of it, as you can see. So it's very inefficient for Power BI to be able to compress this, but we can easily fix this. So I'm going to select it, and then I'm going to go up to split column. And I'm going to choose by positions. Okay, I'm going to backtrack a minute. Cancel that for a second. I think I had something selected out here. That was part of it. Let me just go back to that one spot where I was at. So I'm going to select it, and I'm going to go up to split column in the ribbon, and I'm going to choose by position. And I'm going to tell, and what I'm going to tell it to do is I want to split it right after that year, 2020 or 2003. So there's roughly, I like it to start at 0 and then go out 8 characters. So I'm going to go ahead and click OK. And when I do that, I can see that it splits it up. And even better, it has a correct data type that looks like date for the start date and time for our other start date at 12 a.m. So the data type looks great. Now, if we don't have the correct data type, a lot of times what will happen is you'll get errors and it will render up blank. So that's something to consider. And so there's a good option. What I want to do with the product table, though, is as I look through it, I like to add some additional some additional fields. One of the things that I also might want to do, actually stop. I'm going to skip that section about renaming the table names. We'll just skip that. So what I'd like to do is I'd like to add a field to this table. And what I want to do is I'd like to do a dealer markup field. So I'm going to use this dealer price field and the field called list price to create a new field. And they both have similar data types. They both have the currency data type, so that's helpful. So what I'm going to do is I'm going to use one of the 300 transformations that we have available. And I'm going to add a column. So I'm going to click on Add Column. I'm going to go down to Custom Column. So you can do one of these here a lot of different ways. This can be done a couple different ways. This could be done through DAX as an option. I could do this in mQuery. As a matter of fact, here in Power Query, mQuery is our native language here for Power Query and the Power Query editor here in Power BI. So I could write this out in M, but I'd like to use this easy interface here. And what I'm going to do is I'm going to find list price and insert that in. Then I'm going to subtract that from the dealer price and insert that in. So again, I could have written this out in the mQuery language. I could have gone into the Power BI desktop and written out in DAX if I wanted to for the custom column, which would essentially be a calculated column. They both fall under that umbrella of the custom column and the calculated column, both under the umbrella of the custom column. So the calculated column with DAX in the Power BI desktop is a type of custom column, and then the custom columns are created here in the Power Query editor. These are created with the mQuery language. So I'm going to call this new field dealer markup. I'm going to go ahead and click OK to that. And now we should have a new field called dealer markup. And it has a lot of nulls in there. Not everyone has a middle name. So I have to figure out what I'd like to do with some of these nulls. And there's a lot of nulls in here. So what I can do is I can go in and I could right click the field, middle name here, and I can replace values on it. Now you're seeing that I'm right clicking a lot, but you can get a lot of this off the menu. There's another way to do it, but I want to replace essentially every place where it says null with something else. Now, since this is a text field, I could type something like not applicable. And that might not be too bad of a way to go, but it could be that we're working with numbers. Maybe I want to make it 0. Maybe I want to keep the null. You have to figure out what type of data we're talking about and how you want to address it. So for some people, They might not have a middle name, so we could add, like you can add this in, and maybe that looks too wordy. We can kind of trim it down too if we'd like, but we do want to figure out how we're going to handle nulls. The last thing I want to do is a merge. So this is a very helpful option. What I want to do is I want to merge the fact internet sales table with the date table, the dim date table. And I want it to tell me the internet sales by order date. So I'm going to create a new table to do that. And one option, of course, is working with merge. The other is working with append. They both do kind of the same type of thing. Yeah, you can remember append is like a copy pasting. It's like copying and pasting two tables together into one table, putting it in the same or separate table if you'd like. And then if we go into merge, merge is technically the equivalent of a SQL join. And the append is technically equivalent of a SQL union join. If I go into merge, I'm going to make a new table out of this. I actually want to do this with the fact internet sales table, and then I also want to connect with the dim date table. So what you will see with this is that I can go in now and say how I want the two tables to be able to be joined together. And how I'm going to do this is on the date key in the dim date table. And you should have that on the internet sales table somewhere also. The order date key, that's the one. Okay, this is what I want right here. Order date, and then down here, dim date. It's the date key. So I want to do a join based on the two fields that we have here where we have matches. This is a very common inner join. Right here is what I'm going to do. So I'm going to choose that. I'm going to click OK. And then I'm going to create a new table. It's going to create a new table for me that I can rename. So internet sales by date is what I choose for this new one as its name. So internet sales by date is what I choose for this one as its name. So that's what I can do, give this a rename out here if I'd like to do that. But I essentially have a join between two tables based on what they had in common. And then, as I mentioned, it keeps track of all the steps that we've done here in applied steps on the right. And if I want to get rid of it because there's no real undo here in the Power Query editor, I can click on the little red X. So there's no undo button here per se. Inside of the Power Query Editor, there's no undo button. There is one inside of the Power BI desktop, but here what you want to do is simply hit the X next to it. And then again, I want to see if I can see whether it's the View Native Query is available. Also, that's another thing to check out here. And if I don't see it darkened in, that means it can't roll up into a single select statement. So this may not be an effective query for performance. Our better way, of course, is to reorganize this so all the ones that are that can be query folded are moved to the top, and the ones that cannot be query folded are at the bottom. And we want to aim to get towards query folding, where we can write all transformations into a single select statement. So this lab that you may want to do is going to give you a lot of heavy lifting on how to do transformations, but putting all of it together and then just going through and doing the transformations that we haven't covered are going to be very, very helpful. And there's a lot of steps to do in the lab. Remember that there are 300 transformations that can be done. We're not going to cover all of them, but you may find it helpful to work through some of them. So we want to figure out if we need to fix our data, and in some cases you can do the data, and in some cases you do because the data can be dirty. So you will have a lot of this on your on the hands-on lab coming up, and I suggest working through it to see some of the transformations that we just didn't get to. So see you next time. Thank you for listening. Now you may want to do the Load Data in Power BI Desktop lab. In this lab, you will load data in the Power BI Desktop and apply transformations to each of the queries created, and then load it into the data model. Remember that the lab instructions and the lab files are available in GitHub. And also, the labs are self-contained. You don't have to have completed the first lab to do this lab or any other lab for that matter. Now let's take a look at our transform data knowledge check. Question 1. What is the risk of having null values in a numeric column? Answer: that function average of data will be incorrect. Question 2. If you have two queries that have different data but the same column headers, and you want to combine both tables into one query with all the combined rows, which operation should you perform? Answer: append. To recap this section, we talked about how to clean data for readability and accuracy, which can be truly overwhelming, but a necessary process in making certain our reports and dashboards tell the accurate organizational story. This is the transformation phase of the ETL process, also known as how to shape your data in preparation for modeling and calculations, and then report and dashboard creation to come. It was a lot of heavy lifting with renaming columns and tables, removing unnecessary fields and rows, changing data types, merging, appending, pivoting, unpivoting, and more. I hope you got a lot out of this section towards helping you to understand how to shape your data. See you in the next section.